everybody, and welcome again to another episode of the Risk Matrix with James Junkin and myself, Dr. Martin. And we're here to talk about all things risk. And today we got a great topic. James and I are going to talk about confined spaces and the hazards that go along with those, some training tips for confined spaces, things that are required by the regulations. But before we do that, James, can you tell us a little bit about our sponsor for today's episode?
Absolutely. This episode, the Risk Matrix powered by Veriforce, is sponsored by Trinity Endeavors. Trinity Endeavors is an industrial supply company that prioritizes safety, transparency, and solutions. So they're located in Stanley, North Dakota, and Trinity Endeavors maintains the highest standards of quality and service by combining experience and the latest technologies and manufacturing available, servicing accounts nationwide on products that include PPE, gaskets, fasteners, and high quality 4-gas monitors, which is going to be important in what we're talking about today. So Veriforce members can save 15% off the purchase of a PM400 series gas monitor for worker protection in hazardous atmospheres. To learn more, visit veriforcenetwork.com/offers/Trinity-Endeavors. So get those 4-gas monitors, take advantage of the discount.
Right on, James. Thanks for bringing us in. So let's talk about confined spaces, right? Because I know Veriforce has just come out, or they're relaunching one of their training programs in confined spaces. And it's one of the things that I really kind of key on as a former environmental consultant and an industrial hygienist. So I'll let you take the lead on this, because tell us a little bit about training.
Well, one of the things I find routinely when we're doing assessments, field assessments of contractors working in the field, is a lack of training when it comes to confined space entry, followed then by a lack of a good process that protects workers when they're in those confined spaces. Many times it's built off of a poor policy foundation. So it all goes together when we're working inside confined spaces. And it simply amazes me. Many people, we spend a lot of time arguing about whether a space is a permit space or not. And I'm like, man, we spent more time arguing about whether it was a permit space than it would have been just run the permit. So a lot of misunderstandings when it comes to permit required confined spaces. They are dangerous, but we work in permit required confined spaces pretty routinely. And as long as we have a process, we respect the process, we train people, we identify hazards, we put controls in place, you can work safely inside permit required confined spaces. But too many times what I see is we just kind of, ad lib.
Yeah, well, so here's the thing, James. You can talk about policies, procedures, written stuff, training, all you want, but if the sharp end of the stick is not implementing those things when they're in the field and they're not using their heads, nothing ever gets done, right? I see this all the time. It's like we got the permit, but the meter, the calibration, we had 3 guys, but 2 of them had to go over here and do this. So we thought he was okay. I mean, a bunch of different things. Implementation is usually where we lose it. I mean, maybe you disagree. Maybe it's in the training portion.
No,
I'm not sure. What's the disconnect here?
Well, I think it's sort of in both. And when I say training, it's not necessarily training of the worker. It's training of the supervisor. Veriforce launched a course to combine all this together, entry, attendant, and supervisor training. But I can have a policy, I can have procedures, I can even have training. But if I don't have good implementation, then, and somebody auditing that implementation, which is also required by the general industry standard, right? Then we get into bad habits, and we have no habits to begin with. And I think one of the challenges of confined space entry, number one, is identifying what the hazards are. What are the hazards and what are the controls? somewhere along the line, we got to thinking, if we just take a four-gas monitor and drop it down into a permit required confined space, as long as that's good, we're good, as if there are no other hazards associated with confined space entry other than atmospheric hazards. Okay, so today I think we should talk a little bit about, first of all, what is the definition of a confined space? So number one, we can get into it, right?
Yep.
Number two, has limited entry exit. Number three, not designed for continuous human occupancy. Pretty simple.
That's a lot of things.
Is it a permit space? What makes it a permit space? Does it have, or here's the word, I wish they had written, Dr. Martin, it just depends, right?
It just depends.
Does it have or have the potential to have a hazardous atmosphere? So what does potential mean? It just depends.
Thank you. Thank you. It just depends, right? I mean, I talk about this all the time. It's like, it's not permit. Well, why not? Because it doesn't have a hazardous atmosphere. How do you know? How do you know? Okay, I know this kind of is not, you don't want to talk just about hazardous atmospheres, but let's talk about that because it's an easy one, right? Being a former environmental consultant, if you're going into a manhole on a site that had hazardous waste on it or could potentially be, oil in the ground or whatever, there could be a potentially hazardous atmosphere in there. And just because there's nothing in there and I don't see anything is not a reason to just enter that space, right? Do you have historical knowledge? Did you take some readings? Did you check that the pipes coming in and out of it were locked out, right? Because I get that all the time. Well, those pipes are dry, right? We locked it off at the source. Is it really locked off at the source? I don't know, right? So there's the potential, right? And people need to go through those motions to figure that out, right?
I think sometimes we only look at the readings we get on a four gas. We're looking at O2 levels, looking at LELs, we're looking at H2S and carbon monoxide. However, we may be exceeding the PEL of some other contaminant that's not those four, right? So when we're talking about toxic atmosphere, certainly we can understand lack of oxygen. The most common cause of death in confined space is they run out of air, either through some sort of corrosion, natural processes, normal respiration, or we displace the oxygen or whatever, right? We understand that.
Right.
But then when we start talking about toxic atmospheres, almost exclusively we're focusing on, okay, H2S and carbon monoxide. And I don't want to diminish that, but there are other hazards that we're not maybe monitoring for on that four gas, right?
That's right. Volatile organic compounds, right? In a example, a gasoline station or a nearby oil terminal, or it used to be used as a tannery, right? And that was next to whatever you're going into, or the vat or whatever was used for XYZ, and it's leached into the concrete of the vat, and there's something in there that might come out. So you have to have historical knowledge of that space that you're going into in order to make that determination. There's a lot of things that'll kill you, right? It's not just those four things on the meter. That's just the tip of the iceberg, right?
And we gain that.
So I know you don't want to talk about hazardous atmospheres, but
well,
go ahead.
We talked about this in a previous episode when we talked about respiratory protection, right? So when we're talking about atmospheric hazards, you have to make a reasonable estimate of the contaminants, physical and chemical properties, right? So, and in what state it's in. So if we're looking at these type of to monitor for that, the four gas is not going to pick up every chemical known to man, right? So we need some historical context to be able to get the right atmosphere. So toxic atmospheres, including hazardous chemicals or biological agents, whatever that's in there. Again, something I say every episode, just like you say, it depends. Hazards are best controlled in the planning of the work. if we're going to go into a confined space, let's don't just jump down in there unless we're going to go in full blown IDLH respiratory protection and wear supplied
Yeah.
air.
Level A, level A. You know, don't forget about what you bring in there with you,
I want
right?
to talk
Are
about
you
that
bringing?
when it comes to fires and explosions, right? When we have fires and explosions, sometimes it's the chemicals in the space, right?
Yep.
Dust could be part of an explosive hazard. But what about the stuff we're
What are you
bringing
working on?
into the space?
Yep. What tools are you bringing in there? Are you welding? Are you using pipe dope? Uh, are you changing the atmosphere by your very actions, right? You've gone ahead and you've deemed it safe, but then you take something in there and you do an action that's going to make it unsafe. That comes into play when it's a permit required confined space, right? So you got to think about all those things, and I don't think people are, right? They, you know, if I don't see it, you've ever seen that on the site? If I don't see it, it doesn't exist,
That's
right? And you know, we're subject to that in people in our everyday lives, as people in our everyday lives, that if I don't see it, it must not be true, right? And as a scientist and as an academic, my theory is always like, what is it that we don't see that's going to bite us, right? And are we curious enough to want to know, right? I'm not going in that space unless I feel comfortable. But there are a lot of people that we need to protect that don't have that same sense of self-preservation.
Well, I think one of the other things that's challenging to people that we get wrong in confined space is continuous monitoring. Well, we can't write it down on the permit continuously. So what ends up happening is people just monitor at every 30-minute gaps or whatever, or the attendant sitting there and they're not really paying attention to what's going on with the four gas. I mean, you don't go from 0 LEL to 100% like that if you've got any type of energy isolation that's going on, closing off those sources that you were talking about before. So you ought to get some type of indication, just like you don't go from 20.8% oxygen to 0% oxygen like that. There should be some type of readings. But in my experience, and I wonder if this is your experience too, there's a lot of inadequate monitoring going on.
Yes, there's a lot of inadequate monitoring, and there's a lot of misconceptions on when it's time to get out of a space. Okay. I had somebody tell me the other day, well, I know when to get out of a space. I'm like, okay, when do you need to get out of the space? When the alarm goes off. Well, I mean, yes. However, if your attendant, the person who's taking the readings, is paying attention, right? And they're taking, or at least, you know, monitoring the readings as they're going, you should know that things are going south before that the bells and whistles go off, right? Now I get a lot of people that wear, you know, like personal oxygen monitors and stuff like that, but that's also not adequate, right? Because the attendant is not monitoring this unless it's connected to something that the attendant can see. So yes, by all means, when the alarm goes off, get out of the space, right? By all means, let's set the alarms before you would get to an IDLH or to the PEL or whatever it is. But that attendant should be monitoring those conditions, like you said, you know, just kind of not passively, but actively, right? You said 30 minutes. You know, I'm not a fan of that, right? I mean, you don't know what you don't know. So the attendant should be attending, and they should know
Just
way
because your
beforehand when
form
people
says
should be
write it
exiting.
down every 15 minutes or every 30 minutes, that's not continuous monitoring. A lot can change in 30 minutes.
That's correct. That's correct, right? You're not going to walk away and come back in 15 minutes, right? Just like you're not going to say the fire department is my rescue plan, okay? Because unless the fire department is sitting there on site, what's going to happen when the oxygen in that space goes to less than what you need? Okay.
Body retrieval.
What, you know, what's, and well, you need, it's body retrieval, right? Because I don't know any fire department unless they're right across the street is going to get there in 2 minutes or less than 2 minutes.
No.
So, and I know
We
that,
had
I
an
know
incident.
that,
I had a fatality incident with a client back last year, and it took 56 minutes for the fire department to respond. Now, it wasn't a confined space, but it was 56 minutes on site. You cannot hold your breath for 56 minutes. 4 or 5 minutes, whatever, and now we're into severe brain damage, and maybe you make it to
yeah,
the hospital, maybe you don't. But typically those folks are on life support, respirators, and then a week later, the family's having to make the decision to pull them off. So proper planning, having the right rescue there. Ineffective monitoring is worse than no monitoring at all.
yeah, yeah. I agree with you. I just wanted to, I'm going to put myself on the spot because I don't know exactly where it is in the regs, but, I think a lot of people rely on the fire department falsely because they think in the regs it says, if they're within 15 minutes, you have to have a first aider on site and that kind of stuff. That has nothing to do with confined space, right? It has nothing to do with confined space. The first aid standard is a standalone standard. It's not a rescue standard. It's none of that, right? So, I know that gets us a little off topic, but it's a pet peeve of mine when people say, well, the fire department is our plan. Let me tell you something. The fire department is there to stop fires, right? And if there's a fire, they're going to the fire. Okay. And if it's something you didn't tell them about, they're probably not making you a priority. So unless you hire a detail, the fire department's not coming. And they're not coming as fast as you need them. So have a rescue plan, right?
Well,
And make sure that you practice it.
here's what, and there's 1910 146 in general industry, and a very new, relatively new standard compared to how long the OSH Act's been out there. Subpart AA in the construction standard given when dealing with confined spaces, right? And what you're talking about is it's allowed under the general industry standard to summon rescue if it can get there in a timely manner, considering the hazards identified. So if my hazards are low oxygen, I almost have to have people right there ready to come in, because then you look at the respiratory protection standard, and that would be considered to be an ideal H atmosphere. Employees equipped, trained and properly equipped to go in and perform rescues in those hazardous atmospheres. So maybe we ought to do an episode sometime on exactly what a rescue team,
Yeah.
qualifications are, and when you should have them standing by and when you can summon them. But the point is, what does OSHA tell you? Consider the hazard timely, effective rescue. If it's body retrieval, then you didn't have an effective rescue. And
yeah.
So.
And our friend Brent Kettlecamp would say you don't want to be in, probably, I'm guessing what he would say, you don't want to be in those wiggle room areas, especially when you could be largely in the wrong.
Absolutely. Absolutely. So as we go through these things of fires and explosions, one of the issues I see is actually bringing the hazard into the space. There's a very famous Chemical Safety Board video people can go check out of a fire in a confined space from bringing MEK into the confined space to where you blew past the LEL, right? They did that to themselves, and then whatever initiated the spark or the ignition source is undetermined. Well, a lot of people died because of it. How about this one? Engulfment. How many people think of an engulfment hazard? We're so focused on this four-gas monitor, we forget these other hazards like liquids and solids. So you mentioned it about blocking supply lines into the space. All right.
Yeah. I get a lot. Well, that's been turned off. Well, has it been locked out?
Did you walk it back and verify it?
Did you walk it back and verify it? Did you look at the plans? Did you ensure that there's no other way that can come in, right? A lot of historical plants, manufacturing, even in construction, right? You find that you don't know, let me tell you something, a lot of stuff that you don't know will kill you. So make sure that you walk it back, make sure that it's locked out. Water is a common engulfment, right? My friend from the environmental industry, we were working on an Air Force base, and they went down and they said, take off this valve piece. We've already taken the jet fuel, flushed the lines, right? Went down in the confined space. They were doing monitoring, and he started to take the bolts off the flange. And guess what? Jet fuel.
Not good.
Jet fuel. And he talks about it to this day, being boot deep in jet fuel and climbing out of that manhole as quicker than he
JP5,
probably ever has done.
JP6, like kerosene. So any type of static,
JP4.
very fortunate.
Yep.
Very fortunate.
He's very fortunate.
I was down in confined space, kind of like that, in a hydroelectric dam in Michigan one time, and we was in a penstock underneath the hydroelectric dam. It was about a 40-foot diameter pipe, and the water comes down from the upper reservoir to the lower reservoir, spins the generator, and they had done lockout tagout. We were doing rescue on that, and so anytime I'm part of a rescue team, I always insist that we go into the space first, check it out. Because I don't want the first time we see the hazards in the space and become familiar with the space when we're trying to get somebody out of the space, right?
Right.
And I could hear the water running when we got down in this area. Of course, it's completely jet black, dark. You're wearing headlamps. And even though they had performed lockout, tagout, some of the seals were leaking. And we had tremendous amount of running water, ankle deep at a probably 12-degree incline coming from the upper reservoir down. And that presented a lot of different challenges to us from a rescue team as we try to proceed that. At any point, if that breaks, we all drown.
Right.
Okay. So we ended up stopping the job on that and coming up with a better engineering solution. So consider engulfment when you're thinking about going into confined spaces. Can I be engulfed? Do not trust other trades words. You're supposed to be putting a lock and tag. Every person with the potential to be injured shall place a lock and or tag on each energy isolation device. That means all the entrants. Everybody, right?
That's right.
Same thing's probably true with entrapment. Now, entrapment, in my experience, comes typically with complexities of the confined spaces you're going into. So proper planning. Let's don't get down there and find out that we have downward converging walls and all of a sudden we're stuck.
Or we're taking something out of the space and we get pinned. Right?
Absolutely.
We're going down there to take stuff out and rejig or something and put something in like a ladder or whatever. And you go down in there and it's so tight that you get pinned by whatever you release from the walls or sides. Entrapment.
A lot of people be surprised by this statistic. Number one cause of death in confined spaces, they run out of air. Number two is falls. Either they falling or something falling on them. So what's the point here? A good hazard assessment, know what you're dealing with in a confined space, moves beyond just you getting good readings on a four-gas monitor.
That's right. Remember what's in there, but also remember what you're going to take in there, what you're going to do in there. And all the other things that are involved, right? It's not just about the space itself, it's about the entire task.
So what about temperature extremes?
Oh, let me tell you about temperature extremes. A lot of the chemical pharmaceutical plants around this area, they have steam-driven generation for their power, right? And they've got a lot of steam lines underground. Steam lines have to have maintenance, right? And we've had guys on some of my client sites, they're down 30, 40 feet deep in these steam places, and it's hot, right? Cold, I've never dealt with, but I mean, I think probably in North Dakota, where some of your clients are, they probably have very cold confined spaces. So they're temperature extremes, right?
Absolutely.
It exists.
It exists. Right? We got to monitor for that, right? We got to make some sort of determination. Do we need to bring people in and out of the space more frequently? the role of the attendant is super important. And often in my experience, Dr. Martin, the attendant tends to be the least experienced and the newest employee.
That's the guy that
they're
stands at
poorly
the top of the whole
They
watch.
sit on the
right?
bucket in the whole watch and they're looking at this monitor, but there's so many things that go, that person literally has the lives of the folks in the entrance in their hands. That's
Right.
why I'm a big fan of Veriforce's new program, Entrant Attendant and Supervisor Training, because it's not just a generalist awareness training. It's designed to take folks and train them in your company's policies, your procedures, compile with OSHA standards on how to actually perform these type of duties. So
Right.
heat stress, hypothermia, you ought to be considering that in evaluating the space before you go into the space. Now, here's one that a lot of people don't consider, noise and its impact on the worker, but also noise being amplified in a confined space can interrupt your communication, right?
Mm-hmm.
So attendant's responsibility is to stay in contact with the entrance and order them out if they detect any abnormalities, right? Well, are we accounting for noise? We're accounting for noise.
And it's not just a tug on the rope, right? I've had people, well, I'm just gonna tie this around my waist, right? And tug on the rope if there's a problem. So it sounds like something out of a movie, but I've seen it.
Absolutely. And then all the various other, hazards like poor visibility, for example. I've worked in a bunch of confined spaces where visibility was super poor for whatever reason. It's usually dark down there. We got one little headlamp on our hat. We're trying to fill around. Hey, look, have a plan. Let's get some lights down in there so we can have visibility, so we can see the work. That you're creating a really hazardous situation and in violation of some of the other OSHA standards by not having enough illumination inside the space. And then all the hazardous energy wheel that we talked about earlier, right? Lockout, tag out, pneumatic. What else we got?
There are a ton of things, right? And as you're talking about it, we started the episode with let's talk about confined spaces, but really what we are, it always comes back to the system, right? It always comes back to what else is involved here, right? And we've talked about more than just confined space standards. Once you start classifying a space, right? If you find one or more of those hazards, it becomes permanent, right? And then you're under not only the confined space regulations, but you're under other regulations too. You're under monitoring regulations. You're under heat stress regulations. You're under illumination regulations. You're under, and that's where, again, a skilled safety professional comes in, and a good safety management system where everybody knows that, there are a lot of things that go into this, and there's a lot of thought that needs to take place before you start just kind of running into place.
And you may have electrical issues down in these confined spaces. You may have,
depends on the task. You could be welding in that space,
and that uses up oxygen. You be creating fire hazards. So really, successful confined space entry and operations goes back to the same things we've always talked about. We need to identify the hazards and planning the work, evaluate the risk, and put proper controls in place.
right?
So good processes, good procedures. Sometimes you may need respiratory protection, sometimes maybe not. Confined space, training by itself. These are the deficiencies I see in confined space. We want to run somebody through some e-learning stuff or quick PowerPoint and put them out there. Look, you may have to do lockout, tag-out training with confined space. You may have to do electrical training with confined space. You may have to do fall protection training with confined space. There's a lot more involved in that than just, hey, let's go watch some e-learning and click some boxes and talk about the general hazards of the confined space. So whoever's in charge of your confined space program, you should be evaluating that program according to the general industry standard on an annual basis, right? Going back, looking at your permit, seeing what has worked well. He's seen what hasn't worked well. There's just a lot more complexities in confined space entry than just, hey, we're going to go out there and teach people how to use forecast monitors. As long as forecast is good, we're good.
Right. So again, we open up another can of worms, right? It just depends.
Just depends. You go into confined space, it just depends. And it really does. It really does. But hopefully today we can quickly go through, some dangers in confined space. Number one is always lack of oxygen, toxic atmospheres like H2S, the other hazardous chemicals. They're not monitoring for carbon monoxide, but it could be other hazardous chemicals. So we need a historical perspective of what was in that confined space, or what is here that
could be
that may leak in there, because remember the standard says potential, right? Fire and explosion hazards, things that are in the space, things that we bring into the space. Let's forget about dust involving being, potential explosive hazards in confined space. Engulfment, we talked about that. Engulfment, make sure any supply lines coming back to confined space are locked out. In a plant that we go double line, completely double lines.
Entrapment, falls.
Yep. Temperature screens, noise,
Rescue.
and let's talk about rescue again. Of course, you may not know where Mark. I use 18.5 space pretty regular.
I am aware.
And I think a lot of times people have this history about around confined space. And I've worked some technical jobs, but I've also worked some not very technical. What am I talking about? If we ever call a fire department out here to rescue, one, you're supposed to make sure they're available, stay in contact with them, come out of the space, all these things. There's some differences in rescue between what's fire and sub-part AA in construction standards, what's general industry. But without getting too technical here, what we'll do, we'll get a lot of harm way in the event they're in danger. Right? They're in danger. The quicker we get out of space, the better they are. Hear my words, listeners. A tripod is your friend. You don't have to go to fire academy or learn how to use a tripod, right? Simple tripod that's set up with a winch on it.
You test it.
The test is right. Assuming you just don't buy it and put it out there and train anything when it's appropriate to call. But look, if people full body harness will lower that manhole, it's a lot easier to find out a lot quicker. That doesn't require 2 weeks of training. We're not talking about repelling here. How about horizontal entry into the side of the tank? I can train you to put on the SCA walk in there and put some backboard air out. So I think sometimes we got to have this big mistake about confined space rescue, and in many cases they're making this a lot harder than it is. You have to take rest hard. If we got to get road, we got to repel, we got to do that. You can do that from back fast. But going into a manhole and hooking somebody to a tripod and a winch really not that technical. You need to be properly trained on all these things what they said. But let's think about that, because our priority needs to be how we're going to get them out of space.
Right.
The very first thing I always ask when we get people in confined space is, how are we going to get them out?
Yeah.
Okay? How are we going to get them out? Anyway.
Chat. As always. So again, mention where Veriforce Network members can get that training, or people who want to tap into that, because I know there aren't a lot of options out there.
We have instructor-led training for confined space entry, attendant or supervisor training at rescue. It combines in classroom, in-person classroom training, with hands-on training for intended supervisors. So we're going to be able to cover things like how to use a forecast, how to properly evaluate a hazardous atmosphere, how to use an entry permit, when you should record, when it's time to call for rescue, and those type of things. So reach out to the training department at Veriforce. They give you all the information about that. If you're an authorized instructor at Veriforce, if you look into your instructor portal, you can find information on how to add that to your authorizations for courses that you can already instruct.
Awesome. Hey, James, and everybody listening, thank you again for joining us in the Risk Matrix, baby. If you like what we do, hit that like button, smash that subscribe. That's right. And hey, put down in the comments and say something. It's okay. Tell us we're wrong or right. Ask more questions. Reach out to James or myself on LinkedIn. And again, thanks again for you guys for listening to us jibber jabber about safety things and risk things. And we'll see you next time.
Next Tuesday.
Roll
Y'all
Tide.
keep leaving those workers home safe from high hazard jobs.